Hi everyone. Today I'm going to show you about magnetic reed switch. The switch, basically we use this in automation industry. You want to receive a signal of the movement of any components, and you want in points that how it will behave. Based on that, you require our output according to set your limitations or the boundaries of movements of any object. So through this, what you do is actually you use this switch. So first of all, you might have seen this switch. If you are aware, if you work in a robotic industry or somewhere, this is very beautiful to understand this, that how exactly it works and how a small switch can contribute best to your program. So let us understand this, and we will get to know uh, the working principle of this magnetic reed switch. So let's try to understand this, how we actually work with this. Okay, so before that, uh, you need to understand how, if you haven't seen this magnetic reed switch, I will show you how does it actually looks like in the real industry environment. You might have seen this in electronic markets. So this is the reed switch. It's look like this. So basically, it's a kind of there are different type of switches that come as per the requirement that you have in the market or for your own project. So it's come in a cylindrical form, it comes in a cuboidal form, and it's sometimes come in a what do we call, it's a form of like a blade types or anything like you require. So it doesn't mean that what is the shape of this thing is going to be. What you need to understand is how things are working here, because as per the requirement you can set this thing, right? So all right, so this is the uh, main fundamental image that I will try to show you. This is the two kind of pole, you can say, one from your machine side, that is this reed switch. This is not a reed switch, this is a componental architecture of your machine, from where you want to attach this reed switch to get the program from here, right? So basically this is your reed switch, and between that there is a distance. You can see this is a break range. Break range is like this is where your circuit is going to be open, and this is the influence range of the sensing area, that if you contact in the nearby range of this, it means is going to turn on the LED of the magnetic reed switch. So it's like that, it's going to open working. And then you have this two types of workflow, that is normal open and normal close, right? So this is what are like a basic uh, what we call diagram or basic bifabrication of this magnetic reed switch. You have this glass capsule types, or maybe different types, it doesn't matter at all. But inside there's a inert gas. Why do we require this? To avoid the ionization of the gas, because if you use some different type of air, that may be ionized due to electrical current flow. So for that we put inert gas into it. And second, we have this contact plating. Contact plating is nothing but it's just a kind of two terminals that you want to connect for the circuit to be closed. Then there is a contact cap, it doesn't matter at all, right? You have this thing, reed blades. Important thing to keep in mind here is that this, you can see here kind of a rod here. It's a plate kind of types. So this is actually a ferromagnet. Ferromagnets are very easy to magnetize, and if it is magnetized, they both going to attract each other, and when they attract each other, they are going to form a closed loop, which means they are passing the current each other, and they're contributing to the circuit area. All right, so this is how this thing looks like. You have this I have already explained you this thing, that we have two poles, one is left side, one is right side. When both are going to magnetize in opposite direction, they will flow, they will surpass the magnetic effects. So they have different kind of poles, they're going to attract each other. These are the magnetic field lines they're going to possess. So this is the very basic diagram of this. This is how it works. And I have already explained you this construction part. And when you see this, the working principle are so much easy that even if you can think of this, it works very normally. It doesn't have any rocket science. This as first condition is that it doesn't have any magnetic field, that you are trying to put it on the zero state. It doesn't matter whether you have NPN transistor or like a workflow of NPN or PNP. If you have NPN, you try to keep it as opposite. If you have PNP, you are trying to keep it as normal as possible, right? So like you have this first principle is like say that you don't have current flow, the circuit is going to be open, right? Second comes to magnet comes nearby each other. That is the condition where you have provided the current flow, that is the standard industry current voltage flow that you provide, that is the 24 volt that you provide. And you have this this thing which is going to be magnetized, and after that they are going to be in contact, that I have already explained you just now. And after that it's going to be removed from there, right? So if you try to understand, this is important to know, there are the three types of magnetic switch are there in the market. First is it's a you can say a type or it's a kind of a states, but there are mainly three types I would say. That is one is normal open condition, and second one is normal closed condition. I will explain you what are these. Basically, normal open condition means when you try to get apart from your surface of contact, it's going to get apart with. And the second, when we are going to the apart, there is no second kind of pole like a surface pole should be there. There should be a single pole which should remove it apart. Again, the second thing comes to the normal close. The same thing when it comes to the closure, and there should no external poles available inside the inert gas tube, that tube. And third, this is the third one is basically a latching. The latching third one types is basically you have more than one poles, and there you set the condition that when it like goes from, you know, when it like, I will explain you from here, yeah. So one, you try to set the condition that if it is here, it is in the closed condition. If it is apart, it is in the open condition. But there is a, what if you place a two kind of pole here, but you have this one as a single terminal. From there you are operating through a single terminal into the two types of pole, like this and like this direction, like this direction or this direction. So this is called a latching process, where you latch through a single kind of terminal you have. So this is how this magnetic reed switch work, and you get the output, and you set your standard. I will show you application of this. How does it actually, where we work with this. Let's say you have a limitation of cylindrical movement of any machine you have, right? Let's say you want to move to the fourth direction, you want to move it to the back direction, and you have set the limitation that at this position where this cylinder is going to stop, I need to receive this signal, and that signal you can use into your assembly level program. So for that, this is the way it's work, and it's simple, right? Thank you so much for watching this video. Thank you.